the other day. And it is review for us because we did a lot of it back in, I think it was chapter 2. I want to give out some review materials. For those of you going on retreat, I want you to have these in your hands. We don't need it yet, but go ahead and pass them out. So everybody will have these. So again, we're not using these today. I'll just put them away. So just put those away, guys. We're not doing those today. I just wanted to get them out. So what we're doing today is we're in 7-4, and we're problem 3B. We're going to sketch this guy. Now again, this is not the first time you've done this. This should look vaguely familiar. Okay, so tell me what grading. Got to factor. Got to factor everything. You need to factor everything because there's a chance something will cancel, and if something cancels, we will have a hole in our graph. So here we go. Let's factor. Let's see. I can take a 2 out of this. Double check that. I think that's right though. And lo and behold, something does cancel, right? All right. So I'm going to end up ultimately graphing x plus 5 over 2x minus 2. Would you agree with that? But that's what I'm going to be graphing. And because I canceled out this factor, I am going to have a hole at the point -1 comma something, because I canceled out a factor of x plus 1, which means x is -1. All right, so now I'm ready to go. How do I find the other half of this point right here? I plug in -1 for the x in my reduced problem. Plugging -1 in here isn't going to work. Can't have a 0 in the bottom, so you got to plug it in here. So putting in -1 is going to be 4 over 2 times -3. Did you get -2/3? So on my graph, I'll plot the point -1 comma -2/3. And I'll plot it with a nice little open circle. And I, of course, will label it. All right, what else are you going to put in your picture? Come on, what else we got to put in there? Got to put some intercepts in there. So to find an x-intercept, I basically want this fraction to equal 0 for an x-intercept. And the only way that will happen is if x is -5. No. To get an x-intercept, that's an x value, I'm gonna let x be -5. You guys, what happens if you put -5 in here? You get 0. That's an x-intercept. It's the x value that gives you a y of 0. X-intercepts come from the numerator of the fraction. Now, how do we get the y-intercept? We plug in 0. So we're going to plug in 0 for x, and that will give me 5 over 2 times -2, -5/4. So 0, -5/4, if I did my arithmetic right. So we can't keep talking about this. X-intercepts come from the numerator. What makes the numerator 0? Y-intercept comes by letting x be 0. There's no way, okay? What else do we need in the picture? We're missing a couple more things. We're missing the asymptotes. So the x, or the vertical asymptote, the asymptote that intercepts the x-axis, comes from the denominator because we know our denominators cannot be 0. So my vertical asymptote is going to be where x is 2. And then the horizontal one is one that's a little bit weirder. How do we figure out where that is? You can go back to the beginning if you want, or you can do it in your reduced. It doesn't matter. In the reduced version, I have x over 2x. In the original, I have x squared over 2x squared. It doesn't matter. It's going to come out to be 1/2. So my horizontal asymptote is y equals 1/2. And then at this point, hopefully you can connect the dots and get a picture. If you can't, then you're going to have to plot some more random points. Set up a t-chart and just plot some random points to help you. But I think we have enough here. Do you see this shape right here? Kind of framed by those asymptotes. And then what about that side of the picture? It's the same thing, only it's up here. Now, it is normal for them to be opposite catty-corner each other, but they're not always that way. Use your logic. There's no way it could look like this. No way. Because see that right there? Do we have an x-intercept over there? No, the only x-intercept we have is right here. So it can't be over there. It has to be up here. It usually is anyway, but just in case you were wondering. All right, done. All good? Next, here we go. C. What's the good news about problem C? Nothing factors. That means that we're not going to be able to cancel, which means that we aren't going to have any holes. So there's going to be no holes in this picture. So what do I have? I have no holes. What do I have? 5 intercepts. If I let x be 0, if I put zeros in, don't I have -2 for my y-intercept? And what would make the top 0? What would make 7x minus 2 equal to 0? Yeah. 7x minus 2 equals 0, so isn't it going to be 2/7? So like right here, 2/7, comma 0. Right, those are my asymptotes. I mean, those are my whole my intercepts. What about my asymptotes? My horizontal is y equals 7/8 because I have 7x over, remember when we did like this? what about my vertical? Come on now, where do verticals come from? Denominator. So what makes 8x plus 1 equal to 0? What would x end up equaling? Negative 1/8. I put this problem in here because fractions happen. This problem's full of fractions. Doesn't make any difference. Can you see the shape based on what I have? And what about this side? Does that make sense to everybody? So we got a bunch of fractions, but the same shape, same concepts, everything's the same. All right, 7-4 done. That homework will be due on Thursday. Okay. Do you remember doing these problems last year? These are called linear programming problems. Sometimes they're referred to as maximization problems. Don't you even shake your head at me. I know you did these last year. All right, so we're starting at the beginning. Here we go. All right, so there's a lot of stuff going on in this problem. So the first thing, let's see if we can do is fill in this little chart. So in the problem, we've got fertilizer that has nitrogen and phosphorus. And we have two different brands. We've got brand A and brand B. So this is kind of like a matrix where the rows, here are the rows, and then here are the columns. Can we, looking at the problem and just reading it, can you fill in any of these numbers? I mean, can you fill in any of these boxes from the numbers in the problem? So like the first number I see is 180. Where do you think that goes? They need at least 180 units of N. So the total N has to be 180. Does that make sense to you? Look, N row, total column, doesn't that position represent total N? Right, where does the 90 go? Right under the 180, because that's the total P. Brand A costs $10 a bag. Where does the $10 go? The cost of A. Brand A has 4 units of N and 1 unit of P. So brand A has 4 units of N and 1 of P. Do my positions there make sense to you? B costs $5 a bag and has 1 unit of each nutrient. Johnson's Produce can pay at most $800 for the fertilizer. At most $800 for the fertilizer. Can I put that 800 in there somewhere? Is that the total cost? How many bags of each brand should be purchased to minimize the cost? Okay, I'm going to take that out for a minute because I actually want my answer to be less than that. I don't want an 800 in there. I want to be less than 800, hopefully, minimizing the cost. bunch of lines over here. And then there's a thing that says min max. Our job in this problem is to minimize the cost. And how do we calculate the cost? I handed these out with everybody yet. And behave yourself on that. How do we calculate the cost? $10 for every A bag. Let me call that X. So $10 for every A bag, which is X, plus $5 for every Y bag, which is B. Does that make sense to you? Or I just call them X and Y to help me with my graphing. You can call them A and B. It really makes no difference. So this is what I'm trying to minimize. So I want to get the right kind of fertilizer, but I want to keep this as small as I can. That's my job. All the rest of those lines are for what we call the constraints in the problem. So one of the constraints, and I may have given you too many lines there, I don't know how many it's going to take, but one of the constraints in the problem is that my nitrogen has to add up to be at least 180. So 4 for every X and 1 for every Y has to add up to be at least 180. Does that make sense to you? Got it? Now what about, can we write a P equation? Can you do the same thing? Another constraint is this one, which is X plus Y is, greater than or equal to 90. And I'm going to go ahead and throw this one in. Whatever I spend on fertilizer, which is going to be 10X plus 5Y, has to be less than or equal to 800. Agreed? So these are called the constraints. They're kind of like the boundaries of the problem. However much I buy, I got to make sure I have at least 180 of N, at least 90 of P, and I can't spend more than $800. Now, implied in all of these problems is that X and Y are both positive. You do not need to write those down, because if you look at the grid I've given you, isn't that quadrant 1? I mean, here's the x-axis, here's the y-axis. I didn't have anything anywhere else. Does it make sense to you that X and Y have to be positive? Yeah, because what do they stand for? The bags, yeah, the bags of fertilizer I'm buying can't have negative bags. They can be fractions. You can come out with fractions, but you can't come out with negatives. Okay, so now what we're going to do is we're going to take our colored pencils, and you don't need to use color, that really helps me. I'm going to take my colored pencils, and I'm going to graph these. Now, these are pretty big numbers. I mean, 180 is a pretty big number. You can set your scale. I mean, I've given you a grid. You can extend it, or you can change your scale to anything that you're comfortable with. I think I'm going to use tens. So each hash is going to be a 10 for me, but you can use whatever you want. You can extend your picture however it works for you to graph it. I'm going to graph this one right here with my blue marker. When I graph these, cover up one variable and plot the other one. We're doing this is the intercept method. So if I cover up y, if I say y is 0, then 4x equals 180, which means x is 45. So 1, 2, 3, 4, 5. Here is 45, 0. That's the x-intercept for this one. Now, I'm gonna cover up X, and Y is gonna be 180. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm using the intercept method because if I can find the y-intercept and the x-intercept, all I have to do is connect them with a nice, supposedly straight line. You can use a straight edge, so yours is probably straighter than mine. Are you still with me? Now, it's an inequality. That means I have to shade it. Where is this one going to be shaded? Out, above, out here. So it dirties my markers or my board so bad I'm not going to do it, but it's all shaded out here, right? This is all blue, out here, the little thing. Now, on top of that, I'm going to do this one. So cover up one letter at a time. If I cover up X, Y is 90. And if I cover up Y, X is also 90. So I'll connect those. And where is that one shaded? Above also. So at this point, I have shaded in this part right here. Because I have to be above the blue and above the red, so I'm looking at this section right here. That's what you should have shaded on your paper. Now, pop that one in there now. So if I cover up X, what's 800 divided by 5? Well, figure it out for me. Type it on your calculator.
80.
No, it can't be 80.
60? Yeah.
160? So Y is 160, which is right here. And then if I cover up Y, X is 80. Does that look okay to everybody? Now where is that one shaded? Below. So what I want you to do now, excuse me, is try to figure out where you're shaded. You're shaded above red, above blue, but below green. So I think this is where I'm shaded. Look at that, does that make sense to you? Now the answer to the question is going to be one of those points. So we need to figure out which of those points is the answer. Well, I can't do that until I figure out what those points are. So I'm going to figure out where this point is right here. Now there is no way on my graph that I can tell that. If you have plotted very, very carefully, then you might trust your graph and be able to sense it. I cannot, so I'm going to show you how to definitely find it. There's no guessing here. I'm going to definitely find it. That dot is the intersection of my blue and green. So 4x plus y equals 180, and 10x plus 5y equals 800. I'm writing them as equations now. I'm looking for where those two lines cross. Any guess what I'm going to do now? Substitute or eliminate. Now, do whatever you want. I'm an eliminator, so I'm gonna eliminate. But you can do whatever you want. So I'm gonna multiply this one by -5. So -10x equals -100. Looks like x is 10. And if x is 10, then y has to be 140. Actually, I'm kind of close there. 10 comma 140. Is that okay? Well, I hope it's okay, because guess what we get to do? We get to do it again. Only now we're going to find where the red and blue cross. This is where I like color coding. So red is x plus y equals 90. And blue is 4x plus y equals 180. Well, that one's kind of easy to eliminate. I'll just multiply this top one by a negative. So 3x equals 90. I got x equal to 30 for this point right here. And if x is 30, then y has to be 60. Now, if anybody have a question, I did that kind of fast. That's this guy right here. All right, one more time. You ready to do it on your own? Everybody do it on your own. You're going to find where red and green cross. Where red and green cross. Go ahead, you guys do it. You're in your lunch coma and you're just staring at me. Oh, that's good, Bert. While I'm thinking of it. You're the only one to get a perfect paper on the quiz. All right, I got 70 comma 20. Is that what you got? All right, so now we have to make our decision. You are responsible for buying fertilizer that meets the requirements as cheaply as you can. So you're either going to buy 10 comma 140, or you're going to buy 3060, or you're going to buy 7020. Those are our choices. So now what you have to do is figure out how much does it cost. For example, for me to buy 70 and 20, how much would that cost? Well, 70 and 20, use your calculator. I think that's 800, is it? That's my absolute maximum. I hope I don't have to pay that much. All right, what about 10 140? 10 140, I think is also 800. What about 30 60? 30 60. Would that be 600? So what are you going to tell this farmer to do? Buy 30 bags of A and and 60 bags of beef, and it will cost you $600. There is a lot to that problem. Kara's already turned the page. She says, yes, there's another one. All right, here we go. Make sure, by the way, that you have answered the question. You're probably going to write something like, buy 30 bags of A and 60 bags of B. All right? Make sure you answer the question after all this work. All right, here we go. Here's our chart. So we have low, medium, high, cost. All right, we have two factories that produce 3 grades of paper, low, medium, and high. It needs to supply 24 tons of low grade, 6 tons of medium grade, and 30 tons of high grade paper. All right, stop right there. That sentence is full of numbers. Where do the numbers go? Where does the 24 tons of low grade paper go? Total low grade, 24 tons. Total medium is 6, and total high is 30. This is a matrix, so you have the high row and the total column, they overlap at 30. Their value is 30. All right, factory A produces 8 tons of low grade, 1 ton of medium, and 2 tons of high. Does that make sense where I put those numbers? Factory A. Factory A costs $2,000 a day to operate. Factory B does 2, 1, and 8, and it costs $4,000 a day. How many days should each factory operate to fill the orders at a minimum cost? So X is going to be the number of days for factory A, and Y will be the number of days for factory B. And once again, we are minimizing. Sometimes we're maximizing. Remember that last problem we did after we plugged everything in, we took the lowest number, the 600, because we were minimizing. If we were maximizing, we would pick the highest number. All right, so minimum cost is 2,000 X plus 4,000 Y. $2,000 every X day and $4,000 every Y day is how much it's going to cost. All right, what are our constraints? Can you look at that and build some equations for me? What are the constraints for the problem? Huh? 8X, so 8 X's plus 2 Y's, that is the amount of low grade from A and the amount of low grade from B has to add up to be what? Less than, excuse me, greater than or equal to 24? Because when it says we have to supply 24, doesn't that mean at least 24? All right, what's another constraint then? X plus Y greater than or equal to 30. And then of course, once again, aren't X and Y both gonna be positive? They are in all these problems. These are business problems. If you take a business calculus class, you're gonna be doing these. It's a business problem. All right, let's graph it. Here we go. Yes, these are infinite also. Yep. Only they make you do them a weird way and finite. All right, here we go. I'm gonna do this one in red. This time, I think I'll just let my scale be 1. I think my numbers are small enough. So, if y is 0, x is 3. And if x is 0, y is 12. Connect them with as straight a line as you can. And where is that going to be shaded? Out. So out here again. All right, I'll do this one in green. So 6. And 1, 2, 3, 4, 5, 6. There's my green. And it too is shaded out. And then finally, 15 for X. Remember, don't panic, just add boxes if you need to. You can extend your graph. 30 divided by 8. 3.75. This time, are all of our lines shaded above? Yes. So you don't have like a triangle or anything. What you have this time is, you have this shaded. Does that make sense to everybody? If this out here, all this is shaded in. So the corner points, we call them vertices, the corner points are 0, 12, and 15, 0. And then this one and this one. So those are the 4 points that I need to figure out what they are, because the answer to the question will be one of those points. Now, this guy right here, what is he? He is the intersection of green and red. So green and red. So we'll just solve that system. I got 2, 4 for this guy. Did I go too fast? Everybody follow what I just, I mean, I eliminated, you can do something different. But I solved that system to get 2, 4. Now, that guy is the intersection of blue and green. So I got 3, 3 for that one. That's not right. that what you got? Yeah, my picture's off, but that's okay. All right, what happens now? Paige, you're squinting at it. Did I have a mistake? Anybody else get 3-3 when he did that? Yeah. All right, now what? Where do I go from here? I got to figure out which point is the best, and what does it mean to be the best? It means you minimize the cost. So we're going to take each of those points and we're going to plug in 2,000 times the x and 4,000 times the y, and that's going to give me the cost of that point. So that first one up there, there's no x, so 4,000 times 12. So if I go this route, it's going to cost me $48,000 to make the paper that I need. If I go this route, it's going to cost me $30,000. What if I go this route? So it's 2,000 times 2 and 4,000 times 4. I should be doing this without a calculator, but I'm being kind of lazy. 20,000 for that one. And then 3 and 3. Wow, 18,000 for that one. So what are you going to advise this businessman to do? 3 days, remember X and Y are days, so he should operate factory A for 3 days and factory B for 3 days. That will produce the paper that he needs and do it for the minimum cost, which is $18,000. Everybody's gleefully turning the page. There's another one. Now, notice on this one, I did not set up your chart. I mean, I drew it, but I didn't label it. So take a minute, read the problem, and see if you can figure out how you might label your chart. What numbers, letters, words might go where.
No, please continue with that.
What do we mean by optimal solution for the farmer? Cheapest, right? So again, we're minimizing, and again, it's cost. What is his cost? Well, he has 3,000 he can spend on seed. Oh, wait. We don't want to minimize cost. We want to maximize profit, don't we? Read that problem. Don't we want to maximize his profit? The profit for an acre of potatoes is 150, so this is gonna be potatoes. And the profit for corn is 50. So this is gonna be, X is gonna be the number of acres of potatoes, and Y will be the number of acres of corn. Remember, X and Y are almost always the question. So what do we wanna know? How many acres of potatoes are we planting? How many acres of corn are we planting? This is a real life problem. Farmers deal with this all the time. Okay? Tell me about the rest of the chart. Can you put anything else in there? What's the 70? The total, so if I put total over here, then if this is the number of acres, X and Y have to add up to 70. Would you agree with that, or less than 70? So one of my constraints is X plus Y is less than or equal to 70. So however many acres in potatoes and how many acres in corn can add up to be more than 70. Now, what's the 20 and the 60? That's the seed cost. So the potatoes are 20, the corn is 60, and the total is 3,000. And I want to maximize 150x plus 50y. $150 times every x, $50 times every y. I want that to add up to as big as it can be. All right, are there any other constraints besides this one? 20x plus 60y less than or equal to 3,000? And then do we still have our old regulars here? X and Y have to be positive? Yes. We can't plant negative potatoes. Should we go back 2 10s for our scale here? 70 is kind of a big number. So I'll do that first one in blue. And my scale is 10. So 1, 2, 3, 4, 5, 6, 70. 1, 2, 3, 4, 5, 6, 70. Where is my blue shaded? Am I going to shade below my blue line or above? Below. That's a less than. I got to plant less than 70 acres. Bless you. Alright, here's my green one. Let's see, if I cover up, oh crap, is that gonna be 150?
Yeah.
Okay. Alright, and then that one is just 50. And where is that one shaded? Below. So if I have to be below blue and below green, do you think I'm right here in this shape right here? Below blue and below green? So I have 4 points. Some of them I know, 0, 50 I know, 0, 0 I know, 70, 0 I know, this one I don't know. So what am I gonna do if there's a point I don't know? I've done it a whole bunch already today. I saw the system. This is gonna be blue and green. You do not have to eliminate. It's all I ever do, but you do not have to do it just because I do. Do whatever flips your switch. I got 30, 40. Make sure, by the way, that when you're solving, like I solved for y, make sure you put that in the y spot. Y'all good? All right, now let's find our profit. So 150 times 30 plus 50 times 40. So my profit here will be $6,500. Here it's only 2,500. Here it's 0. Okay, wait a second. When we do these problems, we're always finding a maximum or a minimum. These points will always give you both. Obviously, if you don't plan anything, you're going to get your minimum profit. This is your minimum right here. We want the maximum. This is $10,500. So what are you going to tell this farmer to do?
Potatoes.
He should plant 70 acres of potatoes and no corn.
I know what I'm talking about.
You know what you're talking about. Now, if you know what you're talking about, can you do this every single year? No, you gotta switch up the crops. That's exactly right. You gotta switch them up. So for this year, that might be the best option. But for next year, he'll want to plant something else.